Welcome back to Maths with Mrs. J. We're in the middle of a series of videos on solving equations. And we've just introduced the quadratic formula and we've done some examples using it. I did hint in the previous video at the importance of the bit that's underneath the square root sign, this b squared minus 4ac business. We call that the discriminant, and we use a little triangle to symbolise it. It discriminates between what sorts of solutions we get. Now, I want to think about with you how it affects what solutions we may or may not be able to get from our equation, but it's also useful if you don't have an equation but you just have a quadratic expression and you're wondering, can it be factorised, or should I give up on that endeavour? It will also give you that information as well. So I've got a little table here ready to fill in, and I've got the various types of discriminants that we can get. And I wanted us to have a little bit of a think about how these different discriminants will affect the solutions and also give us information about the quadratic expression itself. All right, let's think first of all about the discriminant being 0. Now, if this discriminant is 0, then when you have your solutions, your negative b plus or minus square root b squared minus 4ac over 2a, if that's 0, you're just going to get negative b plus or minus square root 0 on 2a. So we're only going to get one solution. Sometimes people refer to that as a repeated solution because you've kind of got two solutions that are the same, but in essence, it's one rational solution, right? What does that mean in terms of our expression? Let's think about that. So we've got one repeated solution. What does it mean in terms of our expression? Well, what it means is that the expression must have been a perfect square. So it must have been x plus or minus something all squared. So if your discriminant is 0, I've just used a shortening there for quadratic expression, your quadratic expression will be a perfect square. So if you're ever not sure when you're factorising a quadratic expression whether it will factorise as a perfect square or not, you can work out b squared minus 4ac, and if that comes out to 0, you know that's a perfect square. All right, let's press on. Let's think about the next situation where our discriminant is positive and the discriminant itself is a perfect square. For example, we might have the discriminant might be, say the discriminant might be 16 or something. So when we do our negative b plus or minus square root 16 on our 2a, because 16 is a perfect square, we're able to replace that by a rational number, aren't we? So what's going to happen in that situation is that you're going to get two answers that will both be rational. No surds will be required if this number under the square root button happens to be a perfect square. All right, let's pop that in our table. Okay, now what does that mean in terms of the quadratic expression itself and factorising it? What it means is that that quadratic expression can be factorised using normal methods and getting with just rational numbers in your brackets. All right. So if ever you have a quadratic expression and you're not sure, say you're having trouble factorising it. Say it's got slightly unusual numbers and you're having a little bit of trouble splitting that middle term, and you're not sure. If you work out the discriminant and the discriminant comes out to be a perfect square, so 1, 4, 9, 16, 25, 36, any of those sorts of numbers, then you know that in theory at least that can be factorised, so you might as well persist in that endeavour. If you work out your discriminant and it's not a perfect square, then you know that no matter how hard you try and how many different combinations you try, you're not going to be able to factorise that anyway, so you can save yourself a lot of time. All right. Now, the next possible situation is where our discriminant is positive, but it's not a perfect square. So something like our discriminant is 17. So when you get to this step, because that's not a perfect square, the only way to write that exactly is to leave it as a surd. So what's going to happen in that situation is that you're still going to get two solutions, but they're not going to be rational. They're going to be irrational. There are going to be surds involved. So let's pop that down. Now, in terms of factorising the quadratic part, again, the implications there are that you can't factorise it with rational numbers. You're not going to be able to get your two brackets with just normal rational numbers in there. You would have to have surds in there. All right? So if you ever are unsure, as I said before, if you're trying to factorise a quadratic and you're having a bit of trouble, work out the discriminant, work out b squared minus 4ac. And if that's a perfect square, keep trying a little bit longer because you probably will get there. If it's not a perfect square, it's not going to work. You're not going to be able to factorise it. All right, now our last possible situation with the discriminant is that the discriminant could be negative. So say we had the discriminant comes out to be, I don't know, -5 or something like that. All right, so then when you're trying to do your solutions, you negative b plus or minus square root, oh my goodness, of this on 2a. Well, what do we know about taking the square root of a negative number? Well, we should know by now that we can't do that in the real number system. So we're not going to get any solutions in the real number system. So not only when the discriminant is negative do we have no real solutions, but if we were to be presented with a quadratic expression and we wanted to know, well, you know, can this be factorised? The answer would be no, not in the real number system. If the discriminant is negative, that quadratic expression cannot be factorised unless you go into complex numbers, which of course is a whole new ball game. And those of you who go on to do specialist maths in year 11 and 12 will get that experience then.